Hey everyone. Today, since I am not here, I want to go over some stuff that's in your student journal. But in case you don't have your student journal, I am having a paper passed out that has these questions. The only thing missing is the graph because I'm not going to do the graphing part of this. I think you can graph some points. So I just want to talk about these what are called similarity transformations. That just means we have a couple things going on in a problem going from the pre-image to the image, but one of them has to be a dilation. So we're going to have a scale factor going on, either an enlargement or a reduction, along with some other sort of translation, reflection, or rotation. And then I want to go over three problems that we want to identify that similarity transformation. That'll probably be the most tricky part. So, practically speaking, what I need you to do, let's look at this first question here. Here are the ordered pairs that we have. We have A, B, C, and D. And underneath, since I have space, and you should on your paper as well, underneath the translation, let's go ahead and write what we get when we apply that translation. So A prime, I'm going to remember we have to subtract 5 from every x and subtract 3 from every y. So that's going to give me negative 2, comma 3. And then for B prime, 2 minus 5 is negative 3, and 5 minus 3 is 2, so we have negative 3, 2. C prime, 4 minus 5 is negative 1, and then 3 minus 3 is 0, and then D prime, 5 minus 5 is 0, 5 minus 3 is 2. So there is the first round of our transformations. Now we want to apply a dilation, and this shows that we want to dilate it by multiplying everything by 3. So my final result is going to be A double prime is going to give me negative 6, 9. B double prime is going to give me negative 9, 6. C double prime is going to give me negative 3, comma 0. And D double prime is going to give me 0, comma 6. I could go and graph those, but I'm not going to. I just want to write down those ordered pairs. Let's go ahead and go down to number 2. We have 3 points of a triangle here. So let's first apply the dilation that we see. 1/4 means you can multiply by 1/4 or divide by 4, however you want to think about it. So R prime is going to be 3, comma 2. S prime is going to be 2, comma 0. And then T prime is going to give me 0, comma 1. So those are the results of multiplying every number by 1/4 or dividing it by 4. And now let's do the reflection over the y-axis. A little reminder, that is where when you take an ordered pair, the rule says that you take your x and make it its opposite and keep the y to be the same. Therefore, R double prime is going to give me negative 3, comma positive 2. S double prime is going to give me negative 2, comma 0, and then T double prime is going to give me 0, comma 1. All right, let's do number 3 here. So number 3, if you look at number 3, again, we have a triangle here. We have our 3 points. Rotation around the origin, 90 degrees. That rule says we take an x and a y, and when we rotate it 90 degrees, we get negative y, comma x. So to slow this down just a little bit, x prime means I need to swap x and y. So I'm going to put the 6 and then the 9. But then I need to make what's in the x position, which was the original y value, its opposite, which would be a negative 6. So we get negative 6, comma 9. For y prime, I'm going to swap the x and y and now make the first value its opposite. So I have a negative 3, comma 3. And then for z prime, I'm going to have 6, comma 3. Let's make that first value its opposite, which becomes a negative 6. Then we're going to work at the dilation. So we're going to multiply everything by 2/3. It's still going to be a reduction because 2/3 is less than 1. So we end up with x double prime. When I multiply negative 6 by 2/3, I get negative 4. And 9 times 2/3 is 6. For y double prime, negative 3 times 2/3 is negative 2. 3 times 2/3 is positive 2. And then z double prime, negative 6 times 2/3 is negative 4. And then 3 times 2/3 is positive 2. So those would be my resulting coordinates. Let's go to the next side of these notes for examples. Now we want to describe these. The big thing is we want to just look for two things. And my strategy here is to write down the original points and then the ending points. Let's figure out what happened. So I really just need to focus on any 2 points. I don't have to do all three. So I'm going to pick on N and let's say M. So N is originally 0, 6. I think that's 6, yeah. And then M is 0, 4. I'm going to leave some space here, and I want to get all the way down to N prime, which is 4, comma 2, and M prime is 4, comma 1. Now, first of all, I can see that I'm getting smaller, so I'm going to have a dilation here. And if I see here, I go from a size of 2 to a size of 1, so it's half the size, so I might apply a dilation of 1/2. When I do that, I'm going to get 0, comma 3 for the N. My M will give me 0, comma 2. Now I want to think, how do I get from 0 to 4 and 3 to 2? That also works to get from 0 to 4 and 2 to 1. So 0 to 4 looks like I was able to add 4, which works over here if I add 4. And then from 3 to 2 is -1, 2 to 1 is -1. So I have a rule that says, oh, I can add 4 to every x and subtract 1 from every y. So my final answer here, so here's my final answer, is I would say first we had a dilation, and we could write it fancy. You can say k equals, or you could say x comma y turned into 1/2 x comma 1/2 y. And then we had a translation, or translation means we slide left, right, or up or down. And I take my x or y, and what we saw was we did x plus 4, and then we had a y minus 1. There's my final answer. So let's go to number 5 real quick. Same thing. I'm going to pick 2 points. Let's pick maybe like A and C, just so we're not on the same line. Maybe that'll be easier for you to see. A is going to be -3, 3. And then C is going to be the point -1, 1. And we want to get down to where we have A prime, which is 6, 6. And then I see that C is going to be 2, 2. Now, I can already see that I multiplied every number by 2. Everything's been doubled. But I can also check it because on the bottom here, from B to C is 2. From C prime to B prime is 4. So I'm going to have a K that equals 2, which turns this into -6, 6, and then -2, 2. Now I need to think, how do I get down to, hold on, I'm trying to pick something. All right, I can't pick what I'm trying to get. Here we go. Nope, I'm just messing up. All right, I'm going to stop whatever I was just doing. I'll just leave it how it is on the screen. How do I get to these? Now, what I have, I'm going to mark some things. I have an X and a Y in both of these. And it looks like the only thing I did is my Y's stayed the same, but my X's became their opposite. So that would be me saying I have a rule of maybe -x comma y. Now, how do we get that? You could look at all your rules, and that's going to be a reflection over the y-axis, which you can sort of see in the picture that I literally flipped it over the y-axis and just made it bigger because the AB side of the triangle went from the left side to the right side, but the bottom of the triangle is still your CB. So that's going to be a reflection over the y-axis. So our final answer, I'm going to write this a little bit smaller, I apologize, is we started with a dilation where x comma y turned into 2x comma 2y, and then we had a reflection over the y-axis. You don't actually have to write the rule that says -x comma y. You can just write reflection over the y-axis. All right. You could write the rule to say reflection x comma y turns into -x comma y. That's up to you. All right, last but not least is we have this last problem that has a parallelogram. And again, I'm going to pick 2 points, maybe T and S. So T is 0, 3, and S is 3, 6. Eventually, I want to get down to T prime, which is 0, no, not 0, negative 1, 0, and S prime is negative 1, 1. Let's talk about sides first. Let's corresponding sides. S to R is worth 3. S prime to R prime is 1. So I got 1/3 the size. Okay, so I had a K of 1/3. I got a reduction. That's going to leave me with 0, 1, and then 1, 2 for just that dilation itself, dividing everything by 3, or 1/3 the size. Now, how do I go from all of that to what we have now? Well, I just realized I made a mistake. S isn't negative 1, 1, it's negative 2, 1. So let's fix that real quick. Negative 2, 1. All right, that makes more sense. So if I look at these ordered pairs, the blue ones here and then the image, it looks like my X and Y's got swapped. So I'm going to have a Y comma X. Then it looks like my Y values, I'm going to zoom, make my arrow really big. I now have a negative version of the Y. I'll show you the same thing on this next one. If I swap this, notice that my Y that gets put in for the X value now is the negative version. So what rule says Y comma X? That is a 90-degree rotation. Again, that's because you'll have access to your rules, and you can sort of see that this gets turned 90 degrees. So now SR is on the top, T to Q is on the bottom. So you can sort of see that. But let's go ahead and now write down our final results here. We started with a dilation of 1/3. So I'd write that as dilation. Then I'd write X comma Y turns into 1/3 X comma 1/3 Y. And then I had a rotation 90 degrees. All right. There are some examples that will help you for possibly the quiz that we have tomorrow and possibly the test that we have next week. All right. Have a great rest of your day and good luck on your lesson chat.